We are the truly android life in the known universe. Envision that we're the key spot where there is data in this unlimited system. Cosmologists, generally all throughout the world, are in wonderment of this ceaselessly pushing revelation. The James Webb Space Telescope has gotten the subtle shine of city lights, an inconceivable 7 trillion miles from Earth. Beating all questions, this astonishing accomplishment achieves something other than expanding our points of view as far as what we are and the universe. The hypothesis goes wild as researchers pore over the information, looking for signs that could open the insider secrets of these baffling, staggering helps. The considerations are astounding. Actually, take a look at that. We are continuing in the steps of a couple of uncommon people in the universe, that the universe is spilling over with life and improvement incredibly far outside our ability to understand. Is it conceivable that these distant lights show the presence of extraterrestrial social orders? What's the importance for our insight into the probability of life in the universe beyond Earth? Join us as we look at how the James Webb Telescope recently saw city lights 7 trillion miles away. Sent off into space on Christmas Day 2021, the James Webb Space Telescope was expected to beat the significantly regarded Hubble telescope in capturing astoundingly sharp photographs of recently discovered splendid things, planetary structures, and more. An undeniable target of the JWST is to focus in on the development of the earliest universes by taking a gander at the distant adjoining tenants of the universe. This is useful in light of the fact that the excursion season of light throughout our universe is billions of years. When the JWST collects light, it gets these objects exactly as they were billions of years ago. Space experts measure distances in light years, which is the distance light can travel in a year. To outline this reality, the mission's most significant practical undertaking was an immense field picture that was introduced on July 11, 2022, by U.S. President Joseph Biden while he was speaking from the White House. While the Hubble Space Telescope zeroed in on a lone region of the sky for 10 straight days, beginning on December 18, 1995, the Hubble Deep Field got ubiquity. The region was just a tiny spot making up around 1/1,000,000th of the whole sky. Most of the 3,000 currently intangible things found by Hubble were huge systems followed down billions of light years away. With its consideration on the SMX 0723 system group, the JWST Deep Field covers a correspondingly small sky region. The system plan SMX 0723 is 4.6 billion light-years away, and the more distant galaxies behind it are enhanced by the extreme gravitational field. The supporting of the splendid frameworks is bent into colossal turns where the gravitational field is generally serious. In one case, it was certified that it took a far-off galaxy's light 1.1 billion years to reach the telescope, resulting from traveling through space. The light being delivered stretches as the universe becomes. The main target of the JWST has been to capture visible light from their stars into the infrared. Stargazers can clearly perceive JWST, also evident light photographs of adjacent universes taken by Hubble and other telescopes. By gathering data at those frequencies, we can see how galaxies have developed over a massive time scale and unite into the shapes we notice today. More astonishing than the sheer number of designs in the JWST's first deep field picture is how quickly it was captured, in just hours, compared to days or even months for other telescopes. Wherever it looks, it can't avoid the motivation to find galaxies. Universe gatherings aren't the only objects going about as enhancing main issues. Subject matter experts use the JWST to catch a picture of several galaxies designated VV1191, so they could focus on how the light from one of the pair changed as it went through the other. The later impacts of this study will reveal the properties of the mediating galaxy's advancement. Moreover, apparently the JWST may have truly made an excellent discovery: light from an incredibly far-off galaxy. The declaration of the possible presence of auroras on an exoplanet came from the official JWST site. The deficit of a host star and the cold temperature make it inconvenient to pinpoint where the energy in the upper atmosphere is coming from. In any case, the fact that the object showing auroras is without a doubt producing methane is essential. Without a doubt, like auroras on Earth, they are caused when exuberant particles going from the sun into space are caught by our planet's magnetic field. The charged particles then advance through Earth's air close to the poles, where they bang into gas particles, creating a brilliant light show called the aurora borealis. Jupiter and Saturn have similar auroral irregularities because of the solar wind. At any rate, the usual W1 has no star to orbit, so its auroras are a huge mystery. Everyone's question continues to focus on Proxima Centauri, TRAPPIST-1, around 4.4 light-years from Earth. Inside the Milky Way galaxy, experts have recognized the presence of water on the exoplanet, and the plausibility of life on the world can't be blocked. Are we at last going to see proof of life beyond Earth? Just last month, the JWST saw another phenomenally huge black hole. This giant black hole was seen in various frequencies and is consuming everything around it. This discovery is 40 million times as wide as the Sun. But what's the most ideal importance for us? The JWST has viewed that this incredibly monstrous black hole has been present since the beginning of the universe. Presumably, it won't move. This beast is rapidly consuming everything in its nearby region. The discovery was made by Dr. Lucas Fu and Professor Alastair Z of the Ben Gurion University of the Negev in Israel. As per their discoveries, the very immense black hole is almost on different occasions heavier than the Sun, making it a monstrous substance. Fortunately, it has been found at a colossal range from Earth, around 129 billion light-years away. Still, it is drawing nearer, with the black hole consuming everything around it at a quick rate, as shown by the red shift. When the JWST began sending back its limited data, examiners were energized as they filtered through the information. They quickly believed it was a nearby enormous black hole. When they examined the data using gravitational lensing, they found something even more interesting. The discovery of similar phenomena in other early universe very large black holes has provided new insights into the development of both the black hole and its host galaxy, as well as the connection between the two. This is still largely unknown, but it may be evidence of the early stage development of huge objects like star-forming materials that fell into black holes. Space researchers can't yet see exactly what's happening in the pictures sent back to Earth, but one thing is clear. The James Webb Space Telescope is constantly discovering new odd objects every day. We have the joy of exploring space and being enamored by the staggering lights of planets and stars that float across the universe light-years away. Not only does the JWST allow us to see far beyond what our eyes can appreciate, but it has also revealed a puzzling object in one picture. This picture, which focused on something else, was taken by the European Space Agency, observing two young stars conforming to one another. However, 1.47 light-years from Earth, there is a minute mysterious object, an orange mark at the bottom of the picture, that appears to look like a question mark. Clearly, this little picture is nowhere near I'm material. As a matter of fact, it's enormous. The question mark shape was captured while observing the plans of young stars known as Herbig-Haro objects, which are surrounded by gigantic rings of gas and dust. With respect to the question mark shape itself, the facts may confirm that, due to the two-dimensional picture presented by the Webb, it seems this way from its specific perspective. Right now, we have no idea what it is, and without further study, we could probably never know. At any rate, the discovery has been confirmed by specialists, and it is possible a distant structure or perhaps galaxies that are interacting with each other. The upset question mark shape could be a delayed consequence of their coordinated efforts. Given the surge of distant exaggerated structures revealed by Webb, there is a continuous flood of new erratic solicitations. Everyone's eyes are zeroing in on a specific arrangement of Earth-sized planets that could hold the key to finding extraterrestrial life. The individual leading forward trouble, which includes the shortfall of proof for advanced extraterrestrial life in the universe, not enduring the high likelihood that such substances exist, could finally be settled. Where are these planets? They sit precisely 40 light-years from Earth. Moreover, the nearby star system is known as TRAPPIST-1, which has 7 planets circling it. In their journey to find tenable planets, NASA is taking into account a wide assortment of norms beyond the planet size and distance from its star. A more reasonable methodology is to evaluate the general states of the planet's climate, as this would allow analysts to determine whether the planet is livable. The Infrared Spitzer Space Telescope, which is part of NASA's space exploration mission, uncovered the 7 brutal exoplanets circling the same star, TRAPPIST, a long time ago. The James Webb Space Telescope has now measured the temperature of TRAPPIST-1b, one of those planets. The JWST has consistently made critical discoveries since its launch, and this finding is simply the most recent in a series of record-breaking firsts. This is the first discovery of light produced by an exoplanet as small and cool as those in our own nearby planetary group. No other telescopes have had the ability to measure such weak mid-infrared light. Space researchers were excited when they first found out about the 7 TRAPPIST-1 exoplanets, as these faraway worlds are all Earth-sized and stay in the habitable zone, the region where planets can have liquid water on their surfaces. At any rate, the TRAPPIST-1 planets are beyond our current reach, found an amazing 235 trillion miles away. They orbit a star much smaller and redder than our Sun, known as an M-dwarf star. These stars are far more common in the Milky Way than Sun-like stars and are ideal targets for planet trackers. M-dwarfs are also more prone to ejecting and sending high-energy radiation, which could harm emerging extraterrestrial life or a planet's atmosphere. When we turn our attention to TRAPPIST-1b, we find that it is perfectly locked to its star. One side of the planet is constantly facing the star, while the other remains in perpetual darkness. This difference in temperature creates extreme conditions, with the daytime side reaching temperatures hot enough to melt iron. The dark side remains much cooler but warm enough to prevent the development of methane, a key atmospheric gas. Although this might reduce the planet's actual potential for hosting life, the JWST's ability to measure these extreme conditions offers a unique view of distant exoplanets and their climates. Scientists are particularly interested in TRAPPIST-1 because it has the potential to unlock the mysteries of how planets in distant star systems could develop and sustain life. The system's planets are all Earth-sized and sit within the habitable zone, meaning they are at a distance from their star where liquid water could exist on their surfaces, an essential ingredient for life as we understand it. The discovery of such conditions on exoplanets is exciting because it brings us one step closer to understanding whether life exists elsewhere in the universe. By using the James Webb Space Telescope to measure the composition and temperature of exoplanet atmospheres, researchers can look for signs of life-supporting conditions. The ability to detect atmospheric components such as water vapor, methane, and oxygen could offer clues about whether a planet might harbor life. The JWST discoveries are still in their early stages, but each new piece of data brings us closer to solving the mysteries of the universe, including the possibility of extraterrestrial life. As the telescope continues to send back extraordinary images and data, it is expected to revolutionize our understanding of space, the origins of the universe, and the potential for life beyond Earth. In summary, the James Webb Space Telescope is not only expanding our knowledge of the cosmos, but also inspiring new questions about the potential for life elsewhere in the universe. With each breakthrough discovery, we move closer to answering one of humanity's greatest questions. Are we alone in the universe? The James Webb Space Telescope, JWST, has fundamentally transformed our understanding of the universe, unveiling mysteries that were once beyond our reach. This remarkable piece of technology not only allows us to peer deep into the cosmos, but also has the potential to answer one of humanity's most profound questions. Are we alone in the universe? The JWST's ability to observe distant galaxies, exoplanets, and cosmic phenomena has already begun to yield astonishing insights. As we continue to explore the distant reaches of space, the JWST is enhancing our understanding of the formation and evolution of galaxies. It can observe galaxies that formed just a few 100 million years after the Big Bang, revealing the early stages of cosmic development. This insight is crucial for understanding how galaxies and star systems came together to create the structures we observe today. By studying the evolution of these far-off galaxies, scientists can better understand the processes that led to the formation of stars, black holes, and planetary systems. One of the most exciting aspects of the JWST's mission is its ability to study exoplanets and their atmospheres. The telescope's infrared capabilities allow it to detect subtle signs of chemical composition in the atmospheres of exoplanets, even in distant systems. This could provide crucial information about whether these exoplanets could support life. The ability to detect water vapor, carbon dioxide, methane, and other molecules associated with life is a game-changer. Researchers are particularly focused on exoplanets in the habitable zone of their stars, where conditions are just right for liquid water to exist. In addition to the study of exoplanets, the JWST has also provided new insights into the behavior of black holes. As scientists continue to study supermassive black holes, the JWST's ability to capture detailed images and spectra from these objects is helping to unlock the mysteries of their formation and growth. These black holes are thought to play a critical role in the development of galaxies, influencing their structure and evolution. By studying these cosmic giants, researchers are gaining a deeper understanding of how the universe operates on a grand scale. Another fascinating aspect of the JWST's work is its exploration of stellar nurseries, regions where new stars are born. These nurseries are often obscured by thick clouds of gas and dust, making them difficult to study with traditional optical telescopes. However, the JWST's infrared sensors can penetrate these clouds, revealing the hidden processes that give birth to new stars and planetary systems. This research could provide valuable insights into the conditions necessary for life to form elsewhere in the universe. As the JWST continues to send back data, its discoveries will undoubtedly deepen our understanding of the cosmos. With each new revelation, scientists are refining their models of how the universe works, from the birth of stars to the evolution of galaxies. More importantly, the JWST is bringing us closer to answering the age-old question of whether life exists elsewhere in the universe. As we look toward the future, the possibilities for new discoveries are limitless. The JWST is just beginning its journey, and the knowledge it will uncover over the coming years could revolutionize our understanding of life, the universe, and everything within it.